starting our Google Hangout on the air. So I'd like to welcome Derek Muller. I'm Fenella Saunders. I'm the managing editor for American Scientist magazine, the magazine of Sigma Xi, the Scientific Research Society. So we are really honored today to have a chat with Dr. Derek Muller, the creator and star of the popular science video blog Veritasium, which has more than 1 million subscribers on YouTube. Sigma Xi has named Dr. Muller an honorary member this year, and he will speak at the Society's annual meeting in November in Glendale, Arizona. Just so viewers know, this hangout on the air will be available online for people to view later on YouTube, on Sigma Xi's YouTube channel. And there will be a print excerpt of this discussion in the September-October issue of American Scientist. So welcome, Derek, and thank you so much for joining us.
It's my pleasure.
So maybe we could just start with a little bit of an intro about you. First of all, can you tell me a little bit about what got you interested in science in general, if you have a fun story from when you were a kid or when you were older?
Yeah, I mean, it's a good question. I think I was just interested in science my whole life. And I've got a video actually on my second channel about how, to me, a lot of things seem like magic. That magnets, for example, just seem like magic when you're a kid. But there's a lot of stuff which you just kind of discover as you go, and it seems like magic for a while, and then it turns out that we can understand it, through scientific ways. And I think that's really what drew me into the whole area of science, was just everything that seems so magical, and the fact that we can understand it.
Right, yeah, I definitely agree with you on that. So let's talk a little bit about how you got interested in making videos, because that's a really fun thing to be doing and an interesting skill. And how did you get into that?
I think that is another thing that I just always wanted to do. I wanted to be a filmmaker. I think that's common for a lot of people, especially more and more nowadays, because the tools for filmmaking are becoming ever more widely available. So I was involved with drama productions and plays and musicals, theater, all that sort of stuff, and I really enjoyed that, and I enjoyed the community of it, and also the craft of putting something together that you can be sort of proud of at the end of it. And so I always wanted to be a filmmaker, and I started making films when I was an undergraduate at Queen's University in Canada, and I was making sort of videos with my engineering friends. So we would go out and shoot things with vampires or yetis or just ridiculous things. We were just making stupid comedy videos and stuff like that for our friends. And then eventually, I guess that built up my skills, helped me now make Veritasium.
Right. So first of all, let's just talk about the name Veritasium. That's a really fun name. I wondered how you came up with that. What was your brainstorm?
Yeah, well, I was battling over a name for a long time, and as you know, like securing a .com these days is pretty hard because most of them are taken. So you want something that's cool. I was looking at, like Sci Guy, Sci Flick, Cinema, something like that. I couldn't really come up with anything that I was really happy with. And then one night, I came up with Scientium, which I was like, okay, well, that'll be like an element of science, an element of knowledge. And then it was after that that sort of Veritasium hit me, and I realized that that was a much better name. So it's a bit of a hard one because, I mean, if people don't know what Veritas is, then you're sort of behind from the start, and it's a tough one to remember. It's a tough one for people to stay. But once it catches on, and once people do know it, then it becomes really distinctive. So it's one of those things where having a weird name helps eventually, but initially it's hard.
Right, I got you. We just had a question come in from the audience that I just want to address for 1 second. Somebody was asking me to repeat when you were going to be at the Sigma Xi meeting in Glendale, and that Sigma Xi meeting is on November 8th in Glendale, California, just to answer that question. So, let's talk sort of generally about why you put out these videos on YouTube. What is it that you think that you want to kind of overarchingly accomplish?
Well, I think my mission has evolved over time. I would say now my mission is to help people not fool themselves. That is, I guess, my stated overarching mission in everything that I try to do. So in other words, I think that the world is, subtle, as Einstein put it. It's not always the way it seems. And what I want to help people do is to question their assumptions, to question the way things seem, and and help them uncover, the scientific truths that we've been able to discover. I also want people to just kind of embrace that kind of methodology, that kind of way of thinking, to start thinking about things more critically and more scientifically. So that's really the goal. I think in the early days I was aiming at more people who weren't really well versed in science, and now I aim for a more sort of science-minded crowd. And one of the reasons for that is just because they are a lot more motivated, they're a lot more excited in the things that you do than the, not science-interested crowd. It's like trying to reach a group that doesn't want to be reached. So that was a challenge initially, and so I've sort of slightly changed the direction of what I do.
Right, yeah. It is very difficult to try to communicate with people who are not really interested in looking into science in the first place. So that's an interesting question. And it actually relates to some of what we try to do here with American Scientists and Sigma Xi, because we're trying to help scientists communicate better to the public. And that's actually kind of a hard thing for them to be doing when you have a large percentage of the public that's sort of very anti-science right now. So I wondered if you could sort of discuss ways that scientists could help to make their research more accessible in the sense of what should they be doing, what are the common ways that scientists kind of mess up and make their research inaccessible? What are the things they shouldn't be doing?
Hmm. Well, I guess the biggest thing for me is that scientists should be having conversations with people, and they should be having conversations with people outside of their field, intelligent people who are just uninformed about the area that they're researching. And I think that would give perspective about what people do and don't know. When I went out and asked the questions about when during the day are you the lightest? This is one video I did about, sort of just daily weight fluctuations to try to see what people were thinking. I was really surprised to find a lot of people saying, well, your body is converting mass into energy. That was kind of a stated or implicit assumption of a lot of people that, somehow food was disappearing and becoming energy. And that concerns me a lot. And what's funny about it is it's not something that I would have assumed that people think. Like, I
Right.
would have assumed the property of conservation of matter, is something that most people would hold fairly deeply. But I was surprised to be out on the street and discover even people talking to me about ATP. People who had clearly done a biology course come away from that biology course thinking that still you put food in you and it gets burnt up without really thinking about where the exhaust is or anything like that. So I guess my point is you are always surprised by what people really think about different topics. So if you say the word atom or molecule or entropy or acceleration and you think that that means something because it clearly means something to you, it doesn't mean that to everyone else. And that's where you have to be really careful with science communication, is just making sure that you know the level where other people are at. I guess the converse of that is sometimes scientists think that other people are less literate about particular issues than they are. So then you get into the concern of like being too condescending when you're talking to people about particular issues. So that is again why I think that dialogue is so important, and why a lot of my videos start with a conversation with people, because it's impossible to imagine what other people are thinking, but if you have a chat with some of them, you get to figure that out, and that's a great starting point, I think.
Right. So it's a baseline suggestion, if I understand you, of sort of not making assumptions and trying to understand what the audience actually knows. So do you think that scientists should be asking more questions of the people they're talking to before they actually kind of
Absolutely.
launch into? Yeah.
Absolutely. And I think like when you're giving a talk or a lecture, there should be questions up on the slides. You should be doing show of hands or flashcards or something. The key should be to get their opinions and get them early. And then try to work with that, work that into your talk, rather than just saying, this is the talk I'm going to make. I mean, this is basic communication, regardless of what you're really talking about. But is to really know what your audience is all about, where they're at, and that requires a bit of a two-way street. So the best job a communicator can do is to open up that line of dialogue.
Right, okay. But that requires a scientist to sort of pre-prepare and anticipate different levels of the audience. Is that right?
I think so, but I also think a scientist who gets to know, he will, or he or she will know where the tricky points in his field are, and they will have talked to people before, and sort of you get a sense of it, I think. But for every audience, I think it's worth engaging that audience and saying, what do you think about this, in a way,
Hmm.
eliciting some of those conceptions first before, moving into your talk, so that you can weave in their ideas, and I think that makes it more powerful.
Right, I see what you mean. So, what are the ways, what are the sort of the aspects of the way that you communicate your message that you think kind of draws people in more to your videos? Because you've got a really large following.
Yeah, I mean, there's a lot of different things that I think draw people in. One is things that are just visually amazing to look at. I did a recent video about epigenetics and got some great biology animations from a group in Melbourne, led by Drew Berry, and they're just phenomenal molecular machines. And people love seeing like what's really happening on the molecular scale, and the fact that you can represent that, and for example, show how DNA replicates in real time. I mean, it's so visually appealing and so amazing. I mean, I had another one which was like a two-dimensional Rubens tube. So we had basically this, flame patterns going all over the place and playing music through that. So things that people like, obviously, YouTube is a visual medium. They love things that are visually very exciting and enticing. I mean, that's how you get a really big audience. But people also love ideas that are broken down really clearly, and ideas that perhaps they haven't understood before, explained in a way that they can understand. It's funny, these things like, people are now all concerned with being gluten free. There's a question of like, well, what actually is gluten, and why might it be a problem, or why might it not be a problem? So besides the visual stuff, there's also these ideas that are hotly debated. Um, I think this is one of the reasons why MythBusters is so successful. It's because these are the debates that people have every day, or they've been arguing with their friends about for years, and there doesn't seem to be a clear answer. So if scientists are looking to engage the public, I think the key is to try to target those ideas, those issues that people argue about all the time, or things that are visually spectacular. I think both of those are great ways to go.
Right, okay. So we have a question from the audience that's kind of relevant to this point in the discussion, so I'll just take that one now. The questioner is asking if you remember a particular video or experiment that didn't go the way you thought it would.
Well, that happens a lot. Everything technical is challenging. I did this experiment involving a 40-pound flywheel at the end of a few foot long shaft, this one that you lift up over your head. And the video of me actually doing that, lifting it, spinning at a few thousand RPM, holding the shaft at the far end of this spinning wheel, lifting it up over my head. The time that I showed in the video was actually the third attempt at doing it, and this. I mean the third like real attempt at basically building it. I had built it a few months previous, and we couldn't get it spinning fast enough, and it wasn't balanced well enough, so I was nearly like throwing my back out trying to lift this thing up. And the second time we made it, the shaft was too long, the torque was too great, the precession was too fast. I mean, it was all these issues. I mean, like, so that video, it looks like, we got together of an afternoon and just, spun it up and swung it up over, my head. Was really sort of 3-4 months in the planning, where we'd build one and try to film it and it would fail, and build another one and we had to modify it, and like I had to buy a new drill because we tried it on one day and the drill couldn't get it going fast enough, and so I went out, bought a new drill, the fastest thing I could find in Sydney, like at a consumer place, and that finally got it to work. So massive challenges. I think that's the standard thing with experiments, is for them to go wrong, and so you have to spend a lot of time troubleshooting them. So yeah, that's the way of science. It's the way of technology. There's always going to be bugs. You just got to work through them.
So in some ways, you're doing your own science experiments just by making these videos, trying to get them to go the right way.
Yeah, that's right. I mean, I do almost more science now than I ever did before, and it's all I'm trying to do is communicate science, but we end up figuring out new things as we go. There was the slinky drop that I did, where you have just to extend a slinky under its own weight, and you release it at the top, and if you shoot this in slow-mo, it's a pretty spectacular demonstration how the top collapses down and the bottom doesn't move at all. The bottom just looks like it's levitating. It's totally unsupported, but somehow it manages to stay there. And And that actually led to a scientific paper. So, we were working with some researchers at the University of Sydney who saw that and thought, oh, there's a cool paper in that, did some analysis and computer modeling of what was happening with this Linky, and eventually published, I think, in the American Journal of Physics. So, these are scientific papers that started out as YouTube videos, which I think is a pretty awesome thing to have happen.
Right, so there's a lot more crossover happening now between the actual communication aspects of things and the science itself. It's not just a one-way street like you were talking about before.
Absolutely, yeah. My main goal was just to communicate science, but we end up figuring out new things or seeing things that scientists find cool, and that leads to a paper. So I think that's really neat.
Yeah, actually, I've had a similar experience. I've been doing journalism for a long time, and it's amazing when you interview scientists and you ask them questions, you're coming from a completely different perspective than them. And the greatest thing is when they say to you, oh, wow, I didn't think of that. That's a really great question. That's something else for me to look at.
Yeah, yeah. No, it's great if that two-way dialogue can lead to something productive. I think that's the best.
There's a related question here from another viewer asking if you're working in partnership with universities or scientists. You mentioned this particular study you were doing, so I wondered if that was something you did commonly.
I wouldn't say in partnership necessarily. I mean, sometimes we collaborate on a project. I don't have the means to, for example, build a giant gyroscope, 40 pounds, in my own workshop. So, if I need help from academics or I need help from universities, I give them a shout. I did a series of videos about how quantum computers work, and there was a paper published in Nature out of the University of New South Wales. So I gave them a ring and said, let's talk quantum computers. You made one. I want to talk about how they work. Like, let's get together on this. So I think, at the end of the day, we as scientists and science communicators are all in the same boat of making sure that the developments that happen in science are disseminated widely. And so, we're all on the same team when it comes to, getting the word out there and improving science literacy amongst the public. So, everyone is really a potential collaborator. Any scientist who's doing something awesome. So if you've got something awesome that's visual, if there's scientists watching out there, give me a shout and let's talk about this because that's the coolest thing for me.
Right, yeah. So this brings up another point. One thing I hear from a lot of scientists is there's obviously some advantages, some things that for scientists to be showing their work and to be communicating more deeply about it. That's good for them. It can feed back into their work. It can get them better grants, possibly. It can get them more recognition. But some scientists still get pushback from doing things like that, even within their own departments. I wondered if you'd ever talked about that with scientists and if you had any advice for them about what they can say to even their colleagues about the importance of better communication.
Yeah. Well, I mean, I can speak from my own experience and say that I wrote a PhD and a bunch of papers in international journals, and I guess the expectation with most PhDs is that no one's ever going to read it. But I know for a fact that as a result of making YouTube videos about my PhD, that many, many, many more people have read that than I ever would have thought. Many more people have picked that up. When I look at my citations for the papers that I published, I think they are way more cited than they ever would have been if I hadn't started a YouTube channel. I'm in a kind of a unique area, but I think that general principle holds true. You publish something in an academic journal, and it may, attract a bit of attention, but if you can draw attention to it in other ways, you can really bring it to the top, bring it to the surface for a lot of other researchers in a lot of different disciplines, which I think can then lead to better research outcomes down the track, better citation records and stuff like that. So as an academic, I think the strong counter argument to make is to say, this outreach that I'm doing, this communication to the public is not just a good idea because the public are funding what I do, and they should know where their money's going. But it's also a good idea because it's going to lead to, better research outcomes for this institution. So I think that there is a real practical case to be made for the fact that that doing outreach and communication leads to better uptake of the research that you're doing. So I think it's unfortunate that institutions still are like that, but I do see a lot of them changing to incorporate outreach and communication as real central pieces of what it means to be an academic.
Right. Yeah, I agree with you that I think the attitudes are slowly starting to change, but it's sort of astounding that there's still this amount of pushback that people get sometimes. But so let's say that there is a scientist out there, probably many, who are interested in doing much more outreach and communications about their own research. Um, do you have any specific advice you'd give to somebody about the best ways to connect with the public about their research if they don't have any experience doing this?
That is a very good question. Again, I think the key thing I would say is talk to lots of people. Like get in
Right.
lots of discussions with lots of people who don't already know what you do, who are, way outside your field. And hopefully try to find some honest ones who will tell you when, something's actually interesting and when it's not. But I just I can't stress that enough that, that communication is not one of these things where you go out and blast it yourself. I think this is cool, so I'm going to tell you about it. It's one of these things where you meet people where their interests are. There were a lot of different things, for example, that I could have done with this video about genetics and biology and DNA. But what struck me as really cool was this idea that calico cats are this kind of mottled stripy color because of X chromosome inactivation, this crazy, phenomenon that happens inside the embryo of a female, when it's about 4 days old, and the fact that that happens in humans as well as it happens in cats, and so there's this direct real world connection. Plus, you're teaching some fundamental molecular biology. That to me just said, oh yeah, this is a winner. So you got to look for something that's got a bit of sizzle. I mean, there may be a lot in your research that is really cool and makes a big impact in the field, but there's got to be some aspect of it that connects with the public. I was talking last night about what makes a great video, what makes a really successful video, and I think there's two prongs to it, two pieces to it. One is showing something people have never seen before. In research, that may be fairly easy because obviously you're doing novel stuff all the time. But the second prong is something that's relevant to people's lives. So the more you can get those two prongs happening, something that really plays into the way people think about their world and something that is truly novel, that's when you've got a winner. The Slinky was something like that. It's everyone's seen a Slinky, but no one had seen the way it would fall if just extended under its own weight. So there you go.
Right. So it sounds like scientists, in some sense, not even just for videos, but even for just communicating more effectively, need to be thinking about real-world analogies that kind of draw people in, ways that they can equate things that are not incorrect, obviously, but which sort of give a sense of what it is they're trying to do.
Yeah, and I think that's a very good point. How much can they be simplified when you're trying to communicate with people? I don't think that all the technical detail necessarily needs to be there. I think, it's obvious that you can't do everything. So things have to be simplified down, and sometimes, an analogy can be very helpful. Obviously, I think the thing about scientists is they're always so cautious about, well, I don't want to say this analogy because, it's actually wrong if you look at, X tiny part of this analogy. But that's the point of an analogy, is that it's never going to completely represent the phenomenon because it's not the phenomenon. But the whole point is to give people the idea without having to force them to go through the mathematical rigor. So if it does a good job of sort of serving that purpose, then I think it's right. It's like in movies, the actors are always more attractive than people are in real life, and the storylines are always more dramatic than what actually happens in real life. The point is, what you're going for is not like necessarily this realist truth. What you're going for is an emotional truth. And maybe I'm running too far afield here, but the point is that when you're communicating something, it doesn't have to be perfectly faithful to the original. It needs to be faithful to the ideas and to the sort of the outcomes, and sometimes there needs to be a bit of a mismatch. And I think that's okay, and I don't think it's dishonest, I guess is what I'm saying.
Right, that's an interesting point. I mean, I think some scientists definitely agree with you on those points. For instance, we had an article on supernovas a couple of years ago that was written by an astrophysicist named Andy Howell, and he had been working with a TV program, and they produced an explosion, basically, on Earth that was supposed to be like an example they could use of a supernova. And he said, yeah, it was really awesome, and it was visually beautiful, and it was completely not anything like what a supernova is actually like, but it was still a good example to draw people into what he was talking about.
Yeah, yeah. Well, that's interesting. Huh.
um,
It's,
Go
it's,
ahead.
I mean, obviously to simulate a supernova is not a piece of cake, but people are getting pretty good at it nowadays, I think, with supercomputers and things like that.
Yes, that's very true. So your videos are pretty sophisticated, and that's fabulous. But for some scientists who want to try to ease into this on their own, I mean, can you talk about some things that you've done that are simpler but that were still effective? I mean, have you ever used just like a little tiny camera to go ahead and make a video when you didn't have another resource and it just really came out well? Or the sort of inspirations you can give to people who don't have the means to invest in a lot of big equipment but still want to try to do some things?
Yeah, absolutely. I think the thing that makes a great video, more than the camera or the production quality or the way you edit necessarily, is the ideas and the writing and the way that the video has been thought through. So, there's been times for sure when I've used just like a tiny little GoPro, like a $300 camera or something, and I've just sort of talked to it about various ideas. And then if you edit very meticulously, you can make it very watchable. I think one of the key problems a lot of people have when they first start making videos is there's too long of kind of an introduction of the lead up, and you end up burying the lead. You end up burying the awesome. There's this phrase that I like in science communication or in any kind of communication: lead with awesome. So if you've got something incredible, put it up the front, show people that there is going to be something amazing, something worth looking at this for. Nowadays we're all sort of bombarded with things all the time, and you don't have time to sort of sift through. If someone seems kind of boring or the intro is drawn out, they're not going to stick around and watch. If I look back at a lot of my early videos, what I see is that I'm very stiff on camera, that I don't move very much, that I seem not very animated, and that is something I had to learn, and that took years. And I'm sure at the time I thought I was being perfectly real with the camera. But what's funny for us as humans is speaking to a box, right? Speaking to a little lens or something feels very artificial. It doesn't feel like you're speaking to a human. So you change the way, like it feels wrong to be animated when the thing that you're looking at is like just a little mechanical like box. So it really takes time to get comfortable with it and be able to talk to it as you would another person, and that's really what you need to be doing. I had this invaluable advice on one shoot. I had a producer at the ABC in Australia because I work on a science TV show there, and he said after one shoot, and I thought it had gone pretty well. I thought, yeah, I did a good job, and he came to me and he said, Derek, that was fine, but you know how they say a camera adds 15 pounds? And I said, yeah. He said, well, it actually subtracts 20% of your enthusiasm. So you think that you're at this level, but if you're watching, as an outsider, it's actually it's down a bit. So, everyone who gets in front of the camera has to boost the level somewhat. And I think it takes time to find out where your real sort of sweet spot, where your tone is, where you can really. And this is still something I work on to this day, where sometimes I'll be cutting between different shots, and then I'll find like, oh, I was super high energy in this take, and then I come in like quite under in the next take, and it just doesn't feel right. So in which case you kind of have to reshoot. But anyway, the point is, be more excited, be more enthusiastic than you think you should be. And speaking to a box is artificial. That's going to take time. That's going to take practice. But by and large, you can do really amazing science communication work even with very simple tools. But the key, the absolute thing you cannot skimp on is the writing, the thinking, and the being absolutely ruthless with throwing things out which don't need to be there. I got a friend who also makes these science videos, and we sometimes argue about what I'm trying to do in my videos. And I say to him, no, this bit's really important. I need to keep this bit in. And he said, everything is always important all of the time. So you've got to cut. Like you can't, like everything is going to seem important, but rank your top 3 and make that your priority and get rid of the rest. This is the thing that is so hard to do, but is so essential to do. Is to be able to really prioritize and ruthlessly streamline your discussion to make it, really punchy.
Right, yeah, that's an interesting point because with videos, you don't want them to get very long or you'll just lose people.
This is very true. This is very true. With video, you want kind of little, I don't know if I'd call them winks, or you want little like moments that are awesome. You know, what I say about talks is I view a talk like a salad. You know, a salad has lettuce because that's what a salad is. But people don't eat salad for the lettuce. They eat salad for the like little dried cranberries and the little nuts and things that are added in the salad. And in a similar way, you know, your talk needs to be like that. Your video needs to be like that. It has to have these little golden moments that are worth taking in all of that lettuce for. I mean, the lettuce is important. It's the core of what you're going on about. But there's got to be little bits in there that are really that have, you know, some flair, some appeal, some real, you know, they really zing.
Right, okay. So just one other thing, we were talking about actually having scientists communicate well to the public, but there's also a question of communicating responsibly and making sure that you're not communicating things incorrectly and or too simply or too complex. How do you think scientists can kind of find that sweet spot in the videos that they make?
Yeah, that's a really hard one. As I said, you know, personally, I don't have an issue with some simplification. I think each scientist needs to decide for him or herself what they feel is the appropriate level to talk at, and that's always going to involve some simplification. It's always going to involve analogies which are not perfect because that's the nature of analogies. So I think it needs to be the scientists who are comfortable with what they're doing, and hopefully they don't upset everyone else. I think scientists more often err on the side of being technically correct, and I think that is the real challenge of communicating something in an interesting way. Like, it's not very interesting to have someone say to you, okay, well, by the end of this century, you know, there's a 90% chance of a warming of between zero point 0.8 and 1.4 degrees Celsius, you know, within a confidence interval of X. This assumes, you know, regular cloud cover and blah, blah, you know, all of these, like, this is the way we communicate climate change, right, is in this way that is very much like, you know, you just throw numbers at people and assume, oh, if I tell you some of this data, whew, man, you will be convinced that we need to do something. 2 degrees Celsius, it's a lot of change. Whereas the other side of this debate has on their side the fact that they don't care about facts. And all they care about is a very emotive story. So they can say to you, you know, it's Al Gore and his band of sort of green cronies who are just using this conspiracy to line their pockets with money. And, you know, it's like, well, I don't know where the heck that comes from. But the point is that people respond to emotive stories and they don't respond to statistics and numbers and, you know, things that are essential to talk about when you're speaking within the field. You know, you need to change the message when you're speaking to a more general audience. Does that make
Right.
sense? Am I okay to
Absolutely.
talk about climate change here? Is that
Well,
that's not
actually,
too
that was
controversial?
yeah. Actually, there was a question from the audience. Actually, I was just about to ask you: is about making videos about socially controversial topics such as climate change,
Yeah.
um, about whether you would actually do that and how you would approach them.
I'd love to do it, and I I don't know why I haven't yet. Maybe it's because I've been a little bit like when I do it, I want to do it right, and I want to have time for it to make sure that I phrase it correctly. But with things like climate change, I think it's really important, and it's, you know, to me it's important that I say my truth. I mean, that's Veritasium in a nutshell. Is like, we're not going to mess around with things that are, you know, kind of hocus pocus, whatever. The point of this channel is to get to the meat of the matter about things that do matter and to express them in a way that is open and honest. So I think, you know, if I did something on climate change, which I expect at some point I will, it'll be about telling a clear story which simplifies down and goes for the data. I think it's interesting the way, you know, Al Gore's Inconvenient Truth, I think, is a great example of someone who has stripped out the complexity and he's telling a human story. And he was kind of, you know, a little bit browbeaten over that for saying, oh, you showed this polar bear swimming in the, the melted ocean around the Arctic, and isn't that going too far and all this sort of stuff. But it's really the kind of stuff that people respond to. So in a way, I feel like it's necessary. There's something called the Mythbusters effect that I've heard people talk about, where it's like, oh, well, by watching Mythbusters, you get the wrong impression of science, that you only have to do it once, and, you know, then the outcome becomes clear. Uh, I have really mixed feelings about this because I know to communicate effectively, what you need is a story, and for a story, you normally need, it's an anecdote. It's one. And to a scientist, you think that, oh, this would be much better if repeated 100 times, etc. But the point is, if it's been already established in the literature, if it's already been scientifically established, what the Mythbusters are really doing, although they're kind of demonstrating science, they're more so telling a story, and that is why you cannot, do all the repeatability and statistical testing in that, because it just gets boring and doesn't get anyone on side. So I guess I see a role for, using the anecdote as a way to convey information, where really, as a scientist, what you would want to see is, data and confidence intervals. So I think we need to be able to accept both things, that for different purposes you can sometimes go to different routes, and hopefully that doesn't misrepresent science too much.
Right. That was actually another question from the audience, which you pretty much explained just there, which was, when talking to non-scientists, explaining the difference between anecdotal evidence against bodies of research.
Oh my goodness. Yeah, that's a challenge. That is an awful challenge. And oh yeah, I mean, it's appalling. I was looking at some of the Dr. Oz stuff recently, and just, I don't know. I was recently in Melbourne, and I was incredibly jet lagged because I'm doing lots of traveling. And I went into this pharmacy in Melbourne, and I was looking for melatonin because I had looked at this paper online, a review paper of 10 studies, which says, melatonin, the 5 milligram dose, seems to actually alleviate conditions of jet lag, etc., when taken at bedtime. So I thought, okay, well, it's, scientifically backed up. I will try this thing. And I go into the pharmacy in Melbourne, and the only thing that they sold was melatonin, but it said in green across the label, homeopathic. It was homeopathic melatonin. And then when you try to look for like how much melatonin is actually in these things, all you would see is like melatonin and then colon 6x. I'm not really sure what 6x means. I have the feeling it means it was diluted 100 times, 6 times over. Whatever that means. It means
Right.
there's no melatonin in this bottle, and yet it's labeled melatonin, and the pharmacist was willing to sell it to me as melatonin. But I had to point out to them that this was, in fact, containing none of the ingredient that it purported to sell, and it drove me nuts. And the pharmacist didn't even know what they were doing. I was like, are you aware that what this is a placebo? And she said to me, forget that you know that it's a placebo. This is melatonin. It's like, no, we cannot. That is not the way this works. So I'm not sure why I got on this rant, but it really upsets me the way that things are labeled and marketed, and the way people just don't know. And again, this is another issue that I'd love to take on at some point. Things that people think are effective and just aren't effective. We should be talking about this.
Right.
So I feel a social responsibility to do these things at some point, but I really want to do them so well and smack them out of the park that that they make a big impact on the way we think about the world.
Mm-hmm. Right.
Yeah.
There's another question here. I had it before, and I've got to find it. But somebody else was asking about whether you would do videos about the scientific method as well as scientific results.
I feel like I've done the best video I could ever do about the scientific method. It was this video entitled "Can You Solve This?" When I met up with people on a beach, and I gave them 3 numbers, and I said they obey a rule that I have in mind, and I want you guys to figure out the rule. So you guys have to propose your own set of 3 numbers, and I will tell you, yes, if your numbers follow my rule, and no if they don't. The reason why I think that's the best way of describing the scientific method is because it is so tangible, and and everyone falls into the confirmation trap of saying, oh, well, you say 248, I'm going to say 163264, or I'm going to say 3612. And everything that they say, I say yes to, like because everything does fit my rule. But it turns out in the end, the rule is, any numbers in ascending order. So I think it really brings the scientific method down to a level that everyone can understand, and everyone can see the fallacy that our brains quickly fall into. When we see a pattern, we want to continue it. We want to say that this is the way the world is. But the point of science is that you have to try not to confirm the pattern that you think is there. You have to try to falsify it. So I think, I'm not sure if I could ever do better than that in terms of describing the scientific method.
Right, I see. Okay. So we had another question here. I'm just going to move on and take a couple because we're getting close to the end of our time. Uh, we've talked about this a little bit, but maybe you can be a little more specific. What are some of the most important scientific misconceptions that most people don't know or understand?
Most important scientific misconceptions.
That's a tough
Man,
question. It's a very open question. You've addressed some of this.
it's a wide open field, really. I mean, my zeroth order assumption is that most people don't know the truth about most things. I mean, it may sound harsh, but I feel like when I go out there to ask about what an atom is or what a molecule is, or, I mean, for example, something I think is incredibly poorly understood is, why certain things are solid, like you cannot put one object through another object, that kind of thing. Here's something that I've wanted to do for ages and just have never done, is about what slows your car down. Let's say you're just coasting on the highway and you slow down. And people will talk about, for example, friction, maybe friction between the tires and the road. People kind of view friction between the tires and the road as kind of a bad thing. And it's like, well, why would we make tires out of rubber and the road out of, these things have a lot of friction, like, um, so I think a deep misunderstanding of friction on so many levels. Inertia, anyone who's watched my early videos knows that I was obsessed with inertia for a long time because it's such a counterintuitive concept and such an easy concept for us to overlook, just depending on what particular physical scenario we're looking at. So I harped on and on about inertia, and I mean electricity. Oh, don't get me started. Most people know nothing about voltage, about current, and have crazy misguided notions about these things. So I mean, I'd love to tackle all of these things when I get time. I'd love to do them, and I'd love to do them really, really well. But yeah, that's hard.
It's funny you should mention electricity. There's actually a pretty big debate going on right now about static electricity between two identical objects. You still get static when you rub them together, and nobody's really sure why. So it's a really interesting topic.
Between two which objects?
Two identical objects, identical materials, identical sizes. So
Ah, you still
yeah,
get some static.
yeah, exactly.
Interesting.
Yeah, we should talk about that.
Yeah, yeah. No, I would. I'll be down if we've got something cool to show. I'll do it.
Okay, so another question from the audience is about your audience for your videos, actually. If you're sort of targeting them, what's your target audience? Are you trying to target them towards kids? Are you hoping that your videos would be used in science education in schools and things of that nature?
I know that some of the videos are used in schools. It's not my primary purpose. I think my primary purpose is to reach other people who are just interested in learning about the world. So I kind of think about someone who's a little bit like me, who's just kind of curious about things. I think about what my friends would watch, that sort of stuff. So my target audience is just sort of anyone who wants to find out about the world. It typically, turns out to be people who are already kind of science interested, people who, maybe want to study engineering or science. A lot of the audience is a bit younger, and it does skew a bit male, but that's kind of science for you. But yeah, really, it's inclusive. I'd love anyone who's interested to, join me on this adventure.
Right, okay. So just to get back for a few minutes to talking more directly about trying to help scientists directly communicate better with the public. I mean, obviously, you and I both work in this field of helping scientists do that, but do you have do you have like a tip sheet you give scientists who ask for your advice on getting into this? Do you tell them like equipment to buy, or just, use your cell phone and edit from there? How do you tell people to actually get started?
I think a cell phone is fine. I think any way that they can actually make it work is fine. If they want to get involved, they should do it. People ask me how I got started, but there's no secret to it. It's just you start and you make one, and then you make another, and then you make another, and you try to make them better and better and better. So yeah, there's no tip sheet, there's no crib sheet, but the real message that I would try to communicate is that the careful script, the careful planning of what you want to say exactly, and being very, as I said, ruthless with only the stuff that needs to be there, that is the most important piece of the puzzle.
Right, exactly. Um, But in just in terms of scientists, not just video, but also just trying to deal with their own lab results and things like that. I mean, a lot of scientists now videotape their lab results. Do you think that that kind of material can be incorporated into like a better format for scientists to be presenting what they're doing?
Yeah, it's an interesting question. I mean, when you publish a paper, should you also publish, some of your data in a video form? I think that's a cool thing that we could do going forward, and I think that will help the scientific process, and it'll help really convince people, and again, probably lead to better research outcomes if people are receiving these papers and can also look at the data themselves and be convinced by it. There's one of these great studies that was done about fairness with primates. I don't know if you've seen this video, but it's extraordinary where you can clearly see what happens when you sort of pay these primates unfairly in front of each other. Then all hell breaks loose, and it's I think it can be very powerful for certain bits of research like that, where obviously the subject lends itself to be made into a video. Another other really cool video that I saw related to a research paper was around the way that grains of different size migrate, and they actually seem to result in convective flows when sort of a drum is spun or that sort of thing. So yeah, certain things really lend themselves well to having a video for. So some things really work in video, some things video is unnecessary. But if someone wants to get interested in, or get into video and use it as an adjunct to their research, I think it can only add, it can only benefit, and the more they practice doing it, the better it gets.
Right. Okay. So we've had a couple of questions related to where do you get your sources of information? Kind of what are your favorite places to look for stories and for information about new scientific research?
I always seem to have a backlog of things coming through. I mean, sometimes I do things about new scientific research, and sometimes I do things about old amazing experiments that I've seen. For example, the spinning disk was done in the 1970s by Professor Eric Laithwaite. So I'd seen that one, and I knew it was cool, and that's why I wanted to replicate it. But I don't know. I read a lot of books, and sometimes an idea pops up. Sometimes people come to me with ideas. Sometimes it's comments from videos that are really helpful. For example, I made a video about how trees are able to move water from their roots to their topmost branches, up 100 meters in some cases. And that's a topic that I never would have taken on, except I did this video about how 10 meters is the longest straw you can have. And then I had commenters saying, well, that's great, but if the longest straw that you can have is 10 meters in the vertical direction, then how can trees be 20 meters, 30 meters, 100 meters? How are they actually moving the water? And I thought, oh, there's got to be an easy answer for this, and I thought it was just out there in the web somewhere. But when I actually started digging for it, I found you couldn't get a solid answer to that question, and that's where I really felt like I had to make this question about trees. And yeah, so the ideas come from everywhere, from books, from conversations, from assertions that I hear, from textbooks. I mean, I couldn't believe that I made it to the age of 30 before it really made sense to me how an electromagnet works in this way, that special relativity, like length contraction, you can view the electric field in one frame of reference as a magnetic field in a different frame of reference through the effects of length contraction and special relativity. I couldn't believe that I only did that very recently, and I was just so excited by the idea myself that I needed to get it out there. So the ideas truly abound, and I'm never at a loss for what to do next.
Right. Okay. So another question that's come up, what sort of topics are your most popular in your videos?
Yeah, the most popular ones, like I said, there's the two prongs. Like one, is it something people have never seen before? And two, is it something that people can relate to somehow? Is it relevant to their lives, or is it something that they're kind of familiar with? So the Slinky is a key example that sort of fits both. I guess there's kind of a third, which is it visually stunning? Like there's this levitating disc that I found in a museum in the Science Museum in Paris. Basically, you levitate a 1 kilogram aluminum plate using a ridiculous electromagnet that has so much current flowing through it, like I think 800 hertz or 800 amps, and it's alternating at like 900 hertz. And so I mean, it's just visually amazing to have, and it's the kind of thing that I think at a lot of science museums they would just not allow because of safety regulations. But that was the thing about the Paris Science Center. It's like it's a wonderland where they have not, because of these weird safety precautions, insisted on turning everything off and making everything dull and boring. There's still awesome demos, like, putting electric current through a candle flame, and they just let me go up there and grab these like 20,000 volt paddles and put arcs through a candle flame. I mean, again, visually amazing, something that people can relate to. It's a candle, it's electricity, and it's awesome, and they've never seen it before. I mean, when you combine all those things together, you get a really amazing and usually very successful video.
Right, okay. So I think this is going to be our last question because we're getting close to the end of our time. But this one is referencing your 248 video, which is, again, the one you talked about earlier. And the question is, do you think there's any truth we can take for granted when it comes to science?
Any truth you can take for granted? No.
Right.
Never. That's the whole point of science. Like, if any stone is shaky, then the whole thing is shaky. Like, you gotta really get in there, and that's what we do as scientists. And that, I think, is maybe, I mean, going back to that biggest misconception people have about science, is that science is not this monolithic, static thing. It's a thing that we're willing to change. It's a building that's constantly in flux. So, there's nothing that we can just say, all right, we're just going to assume that that's true. Having said that, maybe there are some foundational assumptions where it's just like, well, because we cannot ever escape solipsism or something, we need to kind of assume that there is a real world. So I will assume there is an external reality external to my brain, and then I will go on and I will do science. So, okay, maybe that's the one exception I'll make. But the point about science is that really everything should be testable and should be tested, until we are so convinced that there's no need to test it any further. And that is how we get to the truth. That's how we've made progress over hundreds of years, and that's what I'm proud to be able to communicate with people and get those ideas out there, because I find them so fascinating and so amazing that more people should know about them. So that is my mission.
Great. Great. Well, I think we're pretty much out of time, so I just want to say congratulations again on being elected into honorary membership in Sigma Xi. We're very proud to have you involved. We're again looking forward to seeing you on November 8th at the Sigma Xi annual meeting in Glendale, Arizona. And there is an open public session that will be available for anyone to attend that you'll be speaking at, so just so that people know that. And thank you so much again for joining us in this video. It will be archived so people can watch it later. So thanks again for joining us, Derek.
Thank you very much. This was my pleasure.
Great. Thank you so much. We'll sign off now. Thank you, everyone.